Welcome to trigonometry. Now, before I move into trigonometry, I'd first like you to know that this is again a very important topic without which you won't even be able to pass your AP test. And the second thing is that this video, the one right now, I'll be only talking about the main concepts that'll help you revise them thoroughly. I won't be diving into each detail. I won't be explaining what exactly a sine value is, what exactly a cosine value is. I'll run through all the topics, I'll just touch them and help you revise them. Now, I'll come with another video after this one, which will be based on important questions from trigonometry. And those are questions which will 110% be asked on your test, or that those type of questions will be asked on your AP test. So stay tuned for that video. Until then, let's revise the concepts before we move into the questions. Now, before we dive into the actual of trigonometry, I want to introduce the concept of a radian. I know the AP test will not directly ask you any question related to radians, but I feel that if you're taking this course, then you should be thorough with the concepts. You should be thorough where a radian comes from. Instead of assuming 2 pi to be 360 and just working with the angles, just by hearting all the angles and stuff, I'll quickly introduce you to a radian and its definition. Now, we all know the definition of a degree, which is based on the fractional part of a circular revolution. But a radian measure compares the length of an arc, that is central angle of a circle, subtends with the radius of the circle. In the figure, angle theta cuts off an arc that has the same length as the radius of the circle. Therefore, theta measures 1 radian. I'll explain what it all means. Now, whenever you have a circle, you always have a center. And the angle subtended by 2 radii is the angle between the 2 radii. There is one minor one, which is the one that I marked, and then we have the major one, which is right here. But we generally refer to the minor one for most of the cases. When they consider the major one, they will mention it, but it is by convention that you consider the minor one to be the angle subtended. Now, we know that radii are equal, right? This radii will always be equal to this radii. But when these radii subtend an arc right here, which has the length same as that of the radius, then the theta becomes 1 radian. That is where a radian comes from. When 2 radii subtend a portion on the circle or arc on the circle which is the same length as the radii, then that specific angle is called 1 radian. And we know that 1 radian, that pi will be 180 degrees when you say pi, or 1 pi radians, it'll be 180 degrees of a circle, which is half a circle. And when I say 2 pi, 2 pi radians, it'll be 360, which will be the full revolution. The only thing for you to remember is this relation of pi radians is equal to 180 degrees. Let's move ahead. I hope that was quite clear to you. Now we'll move on to trigonometric ratios. And before we move on to trigonometric ratios, I want you to know that most of the time in your AP Precalculus test, they will be referring to unit circle, or you will have to use the properties of a unit circle to get your answer. But I just want you to know that trigonometry is a very vast thing, which is not confined to just unit circles and right angle triangles. You'll have the law of sine and cosine, you'll have the graphs of sine, cosine, and other trigonometric ratios. You'll differentiate, you'll integrate sine, cosine, and other ratios. So just bear in mind that it is pertaining to this course that you're fitting everything into a unit circle and the right angle triangle. Now, the ratios are as follows. Oh, before I move on to the ratios, I want to define some parts of a triangle. We all know that this part is the hypotenuse. Now, wherever your angle is, wherever your angle theta is, the line below it would be the base angle, and the line next to it would be the perpendicular one. If this theta were over here, then the base would be this one, and the perpendicular would be this one. I hope that is very basic and clear. One more relation that you all might know is p squared plus b squared is equal to h squared, which is the Pythagorean theorem. And it will be useful for you to exploit the values that they give in your question. So be aware of that. You can use this to get your answer. Now the ratios are as follows. Sine theta is perpendicular upon hypotenuse, cos theta is based upon hypotenuse, tan theta is perpendicular upon base. And their inverses or their reciprocals, sine theta has the reciprocal cosec theta, which is just the inverse, h upon p. Sec theta is b upon h, which is based upon hypotenuse, and cot theta is based upon perpendicular. Now, there is one more thing that I'd like you to know. Also, I like to claim that you'll have to remember these ratios. There is no particular way of retaining this information in a pattern way. You'll have to remember the ratios as they are, just these three, and then you can obviously reciprocate them to get cosec theta, sec theta, and cot theta. Another very important point to note that is your sine theta and cos theta are two important angles, are two important ratios. Now, when you talk about the unit circle, you know that a unit circle has the radius as 1, which means the hypotenuse is 1. Now, since the hypotenuse is 1, sine theta, which is perpendicular upon hypotenuse, would be just perpendicular upon 1. And the perpendicular distance will be the y-coordinate. Alright? The perpendicular distance will be the y-coordinate. So, in general, whenever you see the use of a Cartesian plane and trigonometry, keep in mind that sine theta will be the y-coordinate and cos theta, on the other hand, is based upon hypotenuse. But again, hypotenuse is just 1. So the base in this case would be your x-coordinate. So some important points to remember are that sine theta is your y-coordinate and cos theta is your x-coordinate. Not only will this help you solve more questions, but in the future when you go ahead, it will help you determine when is an angle negative or when is the ratio negative, when is the ratio positive, what would the inverse of this be. So keep this in mind, this is very important. And now let's move ahead. Now this is again a very important table, a very important one. You will have to memorize all the values, but there's a twist. You need not to remember all the values directly. I have a beautiful trick that will help you memorize them, but don't take this lightly. You will have to remember them whether you like it or not. Now I just want you to do one thing is remember the first line, which is sine theta 1, that for theta 0, sine theta is 0. When theta is pi over 6, your sine theta is 1 by 2. For pi by 4, it is 1 over root 2. For pi over 3, it is root 3 over 2. And for pi over 2, which is 90 degree, sine theta is 1. And there are proofs for each of them, but I will not be going into them in this video. Just remember these values. I think I darkened it a bit too much. Yeah. Now that you remember the first line, the way you can write cos theta is that you first write down all of your angles over here and your 6 trigonometric values if you have time in your test. And if you remember these values of sine theta, then cos theta is just the exact mirror image. If pi by 2 is 1 for sine theta, it is 1 for 0. If pi by 3 is root 3 over 2 for sine theta, it is root 3 by 2 for pi over 6. You see how each thing is just mirrored over here. This goes here, this goes here, this goes here, that goes there, and that goes there. So it is just the exact opposite order. 0, 1 by 2, 1 by root 2, 3 by root 3 by 2, 1, and we have the opposite order in cos theta. Now tan theta is essentially sine theta upon cos theta. So you divide 0 over 1 to get 0. You divide this to get 1 over root 3. Divide this, get 1. Divide this, get root 3. But 1 over 0 is not defined. So it will be not defined. Now that you remember all of these values, their respective reciprocals are just the reciprocal of what value they hold. For example, cot theta for 0. We know that tan theta for 0 is 0 over 1. But when you reciprocate it, you get 1 over 0, which is not defined. 1 over root 3 becomes root 3. 1 over 1 becomes 1. Root 3 over 1 becomes 1 over root 3. And not defined, which was 1 upon 0, becomes 0 upon 1. which is 0. Similarly, sec theta is the opposite of cos theta, and cosec theta is the opposite of sine theta, where you just reciprocate to get the values. So you see how just remembering the sine theta one will help you get down all the values of the remaining 5 trigonometric ratios. I hope that tip was useful. Let us now move ahead to the last part, I guess. Here are some very important identities which you need to remember. There are only 3 of them. The first one is sine square theta plus cos square theta will always be 1 for any theta. Tan square theta plus 1 will be sec square theta, and cot square theta plus 1 will be cosec square theta. Now, there are proofs for each of them, but again, I won't be discussing them. I'm only providing you a quick recap, a quick revision for all of the concepts. So, if you ask me, there is no particular way in which you can remember them. Although, if if you move back to the last slide, you can relate them in this way. You have these, I'm going to clear the pen markings. You have sine square theta plus cos square theta, which is 1. And once you get the first two pairs, you skip one. Tan square theta plus 1 is sec square theta. Cot square theta plus 1 is cosec square theta. And a good way to memorize this, I'll write it down here. Just write down the 6 of them in order. Sine, cos theta, cot, sec, cosec. Remember that you have an S sandwiched between two C's. That way you won't confuse between sec theta and cosec theta, because they have similar letters in them which often confuse students. So remember, you have a sine theta, you have a cos theta, you have a tan theta. Then remember, you have a sec sandwiched between two C's. So we have cot theta, sec theta, and cosec theta. Now, sine square theta plus cos square theta equal to 1. Tan square theta plus 1 is equal to sec square theta, and cot square theta plus 1 is equal to cosec square theta. This is a way in which you can remember them. Although I recommend you to do it your way, this is how I remembered them. And I think that'll be it for this video. In the next video, I'll come up with very important questions for trigonometry, which you need to know how to solve before you go and attempt the test. So stay tuned for that. Until then, we'll meet soon. Thank you. Have a good day ahead.